All right, so here's a few news stories you might like. So, as you know, probably William Barr, after Trump tweeted that he didn't like Roger Stone's sentence, he intervened to lower the sentence. So all four prosecutors resigned in protest. So this is the kind of corruption you see in, I mean, I say it's America. This is out of character for America. There are a lot of nations where this is normal. But in America, we're not accustomed to this level of political corruption where the president's cronies get off, but he has the power to pardon people. And to be fair, the most corrupt use of pardoning power in my lifetime was Bill Clinton, who just sold pardons for money to make himself a retirement nest egg towards the end. So it's not like Republicans, the only corrupt ones. But anyway, Trump is fabulously corrupt. And the New York City bar is in fact suing, or has written a letter to the Justice Department inspector asking that the Attorney General be investigated and punished for flagrant abuse of power or something of that sort, which is arguably true. Just like the other stuff that they tried to impeach Trump for, though, it is entirely possible that this is not exactly illegal. It's the kind of stuff that violates norms and is considered abusive, but it may not be that he actually exactly broke a law. Anyway, this one very much surprised me. So China has been very strict at censoring what happens inside China, and also they try to do it outside China. This is why when Trump first got in, the first thing he did was call the president of Taiwan, and that was like, people were terrified because the official rule that China has always enforced is that Taiwan is part of China and they don't have their own president or their own government. You will never refer to him that way. And Trump totally used the wrong word. And it didn't start a huge war or something like people thought it might would, but China is very picky about what they say. And they've been very effective at censoring Americans because all the American businesses are expanding into China. So if a celebrity or anybody at a company says something that offends China and they complain, they will just fire you. So as anybody that expresses a tweet with the Dalai Lama or any kind of support for Hong Kong, their company will get an official complaint from China saying, fire that guy and take it back, or we will kick your branch out of our country. And so anyway, that's what's been going on all along. Now they're trying to pass a law in America forbidding American companies from retaliating if their employees are attacked by China. So I'm still trying to figure this out.
So China can attack people, but nobody can attack China.
Well, but I mean, right now, the companies make their own business decision. And they often decide, like I know teachers are this way. There was a teacher that did something, if you do something rude to like a black student and ends up on YouTube, they will fire you and they don't have to like prove that you broke the law. They just say, look, you're embarrassing our company and you're messing up our business and we don't want you around anymore. And so if you just say something like racist or rude on Twitter, they can fire you just saying, look, you're degrading our company. And so now they're gonna say they can't punish employees for offending China. It said, I'm not sure this is legal. I think this might violate something like freedom of speech or something. It's an interesting, strange situation. You certainly can't tell China what to do. And I don't understand how you can tell American businesses that they can't fire their own employees for a thing like this. It's an interesting issue, you know, because you have freedom of speech in America, but it doesn't mean there are no consequences. It means you can't be jailed for it. But your boss can fire you. Your wife can leave you. Your friends can hate you for what you say. That's all permissible. There are consequences. Anyway, we'll see what comes of that one. So this is one, there've been quite a few of these scandals on Uber. This one is pretty amazing. So the guy goes in an Uber with his girlfriend, and then somebody rear-ended the Uber. And so the Uber driver chased the guy that rear-ended him and wouldn't let them out and was running through red lights until he got hit again. And then he finally let them out. So now he's up for kidnapping and endangering people and all sorts of crimes. That's and they live streamed it all on Facebook with their phone. So that's there've been a few of these cases like that, Uber and Lyft. This guy from Harvard in America says that he thinks that the coronavirus has already spread into America and other nations, and it's just that we don't know yet, and it's going to spread like crazy here, and we'll see if any of this is true. Now this one was pretty interesting. Your Android gets infected, and even if you do a factory reset, it's still infected. And this is interesting because I know this is also true of iPhones. The point is, when it infects you, it creates these folders full of files, and even a factory reset does not remove those folders. I know this is also true of iPhones. An iPhone iTunes Restore does not completely restore all the files. I've tried this myself. And so apparently whatever Android factory restore also doesn't restore all the files. I know in Apple, it only restores whatever they think you should have been changing. But if you've been changing other things, they aren't restored. Anyway, so this is an interesting issue. There is no image backup. Like there used to be a thing called image backup in like Windows 7, where you could make a backup of your system and restore it, and it would be 100% of the system back. Microsoft didn't like it, and they made it harder and harder to do in each version of Windows. Windows 8, it was hidden. And Windows 10, I think it might be pretty much gone entirely, because Microsoft doesn't care about home users or small businesses. They think everybody should have a Windows deployment server because everybody should be a big corporation, as far as I can tell, and they take away all the other options. But there are third-party tools like Acronis file backup system that will make an image, yeah, and Clonezilla and stuff. And anyway, it looks to me like it might be time to make a image-based backup for your Android or something. Anyway, it's an interesting issue. And this one I thought was pretty interesting. These guys, I saw this last night. Yeah, these idiots have filled their page with junk, so you can't see it. But anyway, a lot of people redesign their pages so you can't see them. Obviously, they think I'm using a different browser or something. Anyway, so these guys created a tool to to find secrets in Android apps. And here's what they found. Thousands of apps. Out of 16,000 apps, 2,000 of them have hard-coded keys or secrets in the app, which is very interesting. And it'd be fun to look for this. This is something I'm planning to add to my Android hacking class. We'll start looking for things. Here's an AWS key. And the one thing that I was confused about is how can you tell if there's an AWS key, because the key is just a long string of random bits, but they call it AWS key. And that's all these guys did. They looked for the name secret or the name key. So if you were to just give it a non-obvious name, you wouldn't be able to tell. But anyway, apparently a lot of apps do have these hard-coded secrets, which is not too surprising. So anyway, this is 129S, and we are here in chapter 5 talking about bypassing client-side controls. And I've shortened this lecture quite a bit because a whole lot of this lecture was about browser extensions that are all gone. The client-side Java, Flash, and Silverlight. And I just took all that out pretty much. Those have all gone the way of the dodo bird, and I don't miss them. I don't think very many people miss them. They were huge security problems and performance problems, which is what the real death knell of them was, the iPhone. Steve Jobs absolutely refused to put Flash on the iPhone. At that time, when the iPhone first came out, everybody used Flash, and he said, this is garbage. It's buggy, it uses up my battery, I'm not going to do it. And since you couldn't see Flash on the iPhone, everybody quit using it on their website. And after that, pretty soon people quit using Java, and Silverlight never went anywhere, and all these things pretty much went away.
You didn't put Java on the iPhone either, right?
I don't think so, although Android runs on Java, but not client-side Java. These things called Java applets that would download and run in your browser were like Flash, and they're also gone. Nobody's doing that anymore. All these things, they've all just been replaced by HTML5. As far as I can tell. Yeah, and also by JavaScript. That was the big thing. About 10 years ago, Chrome and Firefox figured out that they could make JavaScript run 100 times faster. And then you didn't need these other languages. You could just do things, whatever you wanted to do in JavaScript. So anyway, the fundamental problem here is client-side controls. And I mentioned this in the early lectures. The issue here is that people run script on the client in the browser, and then important things are done there, and you can't trust anything that runs in the browser. That's under the control of the client. But developers often don't think about that or realize that scripts are on the client. So they send data to the client, and then they get data in a later request from the client, and they believe it as if it was trustworthy. But in fact, it has bounced off the client, and the trustability has been modified. So this like shopping carts. This is, of course, often a huge time saver, because often your company has partner companies and other branches that you don't know how to talk to, and you have to take something that came from them and move it over here. And the only way to reasonably get it there is to put it in the client's browser and back over here, because you don't really have a communication medium to go from one server to the other inside the company. And the best thing to do is just bounce it off the client. So this is something else I mentioned about a month ago. There was a survey that discovered that the #1 predictor, I hope I remember to start recording. Let's see what this chat message is. Oh, Henry's, Bananas Republic. Yeah, it's probably, that's the political stuff. And I think I remember to start the recording. I did, good, all right. So anyway, the number one predictor of insecure software is organizational chaos, where you have many different departments and they don't really work very well together and nobody knows who the boss is. That's the biggest problem, which certainly makes sense to me. Anyway, so let's take a look at some of these client-side controls. I've got a page full of this stuff here. And let me run this through Burke. So I got Burke listening here. That's not Burke. Let's find Burke. Here's Burke. Okay, I'm going to go to the proxy, and I'm going to clear this old stuff and go to options. I've just got Burke listening on 127.0.0.1 because I'm just trying to catch traffic from this browser here. So I just go into preferences and proxy, and I just set it here to 127.0.0.1.80.80. All right, so here's my page. And if I refresh that page and look in Burke, there it is, the request to load the page. So I am able to catch traffic in Burke. So here, buy an iPhone. Let me just make this big. Buy an iPhone. I submit, and I bought a phone for $449. And the issue here is, if you look at that request, it sent, let me make this fit on the screen a little better. It sent the quantity here and the price here. It sent the price up from the client. Now you do want to display the price on the client so the customer can see it, but you shouldn't believe a price that came from the client. So if you want to buy a phone for less, you can send it to the repeater. And in the repeater, I'll get rid of the old one. This is where you can just repeat a request. So I can just change the price to say 44 and go. And then over here, it did let me buy a phone for 44. So it believed the price that came from the client. So it's that easy. All right. So that's one form of client-side controls. This price was not modifiable by me, but it is modifiable if I use Burke. The developer figured I couldn't change it because they didn't give me a field to type into here, but I can change it by intercepting the traffic. So here's, you might want to get a discount. So you click here. Now you have a 10 discount. So if I buy one now, I'll get it for a discount of 10. And so if I look at the requests that caused that, here I am, the first request set a cookie. And so I made the request. If you look at the response, this set a cookie with discount equals 10. Then when I did the buy, it made this request and it sent up a cookie with a discount of 10. And then the response, I can render it. Response was, you got it with a discount of 10. So it's pretty obvious what to do. Pretty much the same thing as before. You send it to the repeater. And this is the one I can make my discount 100 by changing the contents of the cookie. And if I go, now it's going to tell me you got a discount of 100. So it's very much like the last one. It's believing something that was in a cookie. And the problem is there's nothing to stop me from modifying that cookie. All right, so let's try some more of these. Here's buy a phone. And I'm trying to buy a phone for 50 bucks. So I buy a phone here with one and submit. And in this case, the parameters are just right up there in the URL. Quantity equals 1, price equals $4.49. These are get parameters instead of post parameters. And this is the same story. I can just change that to another number, and now I get that other price. So these are all very similar and all pretty trivial to do with Burke. This one you don't even need Burke for because you put stuff right in that bar. Then here's the referral. So if I try to submit here, it says, no, you can't do it. You could only do it if you came from apple.com. So this is a common trick. They don't want you to come from some other site. They want to make sure you came from the right previous page. But of course, the referrer is not anything that's validated. The referrer is just part of a request. So when I go here and get it, and it sends the referrer here, I could just change that referrer. So again, I send it to the repeater. And here I just change the referrer to https apple.com. And now when I go, it says, good, you bought a phone from Apple. So you trusted something. This, by the way, is everywhere. people, the whole point of spam email is you send email with a fake from address, and then when people complain, the complaints don't come to you. This is swatting. Swatting, you call the cops and you say, I've got a hostage and I'm going to kill them, and you change the caller ID to point to somebody else's phone, and they will believe it and drive down there and raid that house with a SWAT team. Many, many people believe these from addresses that are not verified anywhere. And this is all this is. The referrer is just the same. It's a record of where it came from, but it's not verified in any way. So it can easily be a false record. So here's a length limit. I'm trying to buy 10 phones. So if I try to buy 9 phones, it works. And if I try to buy 10, it won't even let me type the second character, because this field has a length limit of 1 character. You can't put in more than 1 character. So I can't do it in the context of that form, but of course I can do it this way. I find the request here that made 1, and now I can send that to the repeater and change this to 10. And the point is, there's nothing actually preventing this parameter from rising above 10. It's just that I couldn't enter it in the form. So now you bought 10 phones, because I just modified the traffic on the way out without using the HTML form, which had a limit in it. Here's script-based validation. So here I put in 4, and it lets me buy 4. I put in, but if I try to put in 6, it says quantity too large. And notice this did not go to the server at all. This is client-side JavaScript running in my browser, blocking it. So if you take a look at the source code for this page, and go down to say 6, here's 5, here's 6. You can see here it has action equals hidden6.php, and there should be validation somewhere. On return, validate form. This is the way it often looks. So when you try to submit, the first thing it does is run a local JavaScript file called validate form, and you usually put that up here, and here it is, validate form if quantity greater than 5, print out quantity too large. So this is the script that blocked me. Now there are a bunch of ways to stop this. This is real, like what we were doing before, cheating on those binary games. You could just save the file locally, run it locally, and delete the script. You could just turn off JavaScript in your browser so JavaScript doesn't run. You could use command line JavaScript to change things in the command line there. Or you can just use Burke. Of course, Burke will let me do it. So I make a request for 4, which I think I did. So there should be a request that did go through here for 4. So again, I can change it here if I send it to the repeater. And the point here is I am not entering a bigger number in the browser, so the JavaScript never has a chance to stop me here. So now I can do 6, because I just caught the network traffic. I should mention, I think Iron Geek, one of the famous security people, he ran a network CTF where you were trying to hack network protocols. And what one of the competitors did was they found the signals that went to the scoreboard to make points, and they blocked them so nobody else could make any points and just sent signals so they would get points. And he said, they win, that counts. You know, and so that's what we're doing here. I'm just changing the data on the fly in the network. This is also what happens when you get your router infected. There are infections in your router that will change your traffic, like add viruses to your downloads and such. And it's not running in your computer, it's in your router, but it changes the traffic on the way in and the way out. So that's script-based validation. Now here's a disabled field. I want to buy a phone, and there's a price here, but I can't type into it. Now, if you look at the HTML, that's number 7 at the bottom. Yeah, and all you do here is it's a real field here with value equals 449, but you just put disabled equals true here, and now it shows up, but you can't change it. So again, let's send that request and see what the request looks like. So I buy one, submit. I bought one for 449. So if I go to my proxy, there it is. And here, notice it did not even send the price up to the server. By the way, it still has an old cookie for discount equals 10, because once you have a cookie, it will keep sending it to every request to the same server, even if it's not relevant anymore. So it didn't send the price to the server. Now, this is an interesting puzzle. How can I change the price? It didn't get the price from me, but the fact that there's a disabled field there gives me a clue. If I look at the source code, this field is named price. So it kind of suggests that there is another form somewhere where they use the price. So what you can do is in Burke, you can just add another field that's not there by the form. Let's pretend there was a price field. This is what quantity equals 1 looks like. Remember, if you go back to one of these others, let's go back to one. Let's go back earlier to get an example of one where you can change both, like the very first one. Let's do this one, submit, and see what that request looks like. Proxy, here's that one. Quantity equals 1 and price equals 449. This is what it looks like when you have the quantity and the price. So if I just take that and I add it here to this one, like that, the form didn't let me put in a price, but if it had, it would have sent it like this. So I just hit go, and now I get a phone for 44. So the point is the script on the server is still using that field, even though it didn't come from the client. And you can override it with a message from the client. So it is an interesting issue. And well, so that's kind of good, clean fun. And the last one here is to cheat and get this all done at once. And I might need a slide to show me where this is. There is a cool feature in Burke that will let you just disable all client-side controls all at once. And this is client. Now remember I said one way to hack this stuff is to save the HTML file locally and modify it and reload it. And Burke will do it for you over the network. If you go into proxy options, you can intercept server responses. And there's a response modification. You can unhide hidden fields, and you can enable disabled form fields and remove limits, remove JavaScript. Pretty awesome. You can just, now what it does, you load a page, it sends a request to a server, and then a bunch of code comes down, and Burke will just alter the code for you. So if you turn on this jazz, and then just reload the main page, then it's going to show me the hidden field here of the price. And now I can buy the phone for 44. And it's going to just show me a hidden field here that's a price. And here for script-based validation, I can just put in 10 and it will just let me buy 10 because it turned off the JavaScript validation by just removing anything that looked like JavaScript validation script. And here this disabled field is not disabled anymore. So this is pretty awesome.
It took off that disabled parameter.
Yeah, and you can see that here. That's what I did. I just chose to enable disabled fields. So it will just automatically modify everything that goes through to turn off the common client-side defenses. They're pretty, so it's pretty fun. This is the easy way to do it. You can also convert HTTPS links to HTTP, so you can hack them and everything. You can do all sorts, take the secure flag off the cookies. So now the cookies can be sent in securely, and you can't trust anything from the client. And by the way, you can't really assume that anything you put on the server really made it to the client. They could have modified the data coming in too. So you have to think in a suspicious way to make things secure. All right, so we've seen this, and I think we've done quite a bit of this. By the way, sometimes when you're using a request, you'll get this garbled zip stuff. So if that happens, take away the accept encoding. The default in most browsers is that it will accept gzip encoding, and I should be able to demonstrate that. Let me load a big page, like, I wonder if I have a big enough, what happens if I just load this home page? Let's see what that looks like in Burke. I may not be able to have an easy demonstration of this, but let's see. This is a fairly big, let's see, I need to do Shift, Control, Refresh. That should do it. Control, Refresh, Shift, Refresh. Shift refresh. Yeah, it really was reloading the page. That's what I want. And I'm hoping that page is big enough. See, this says accept encoding gzip. If you look at the response, not found. Here's the one. Okay. The response is, this one came through in plain text anyway. Anyway, I don't know where I can get if you get a big page, it will zip it and you'll have garbled junk you can't see in the response. So if you want to get it in plain text, you just take away this line, and then it will always give you plain text. It won't compress the results. Anyway, that's a common irritation when using Burke, is you send a request and what stuff you get back is zipped. Of course, you can unzip it, but you can just avoid the bother by taking out that line. So you can, by the way, you can modify things more than we've done in Burke. You can match and replace. Here's something you can do to require non-compressed responses. If you don't want to just manually remove the line, it has examples here. Ignore cookies, rewrite host header, and so on. Burke has a lot of settings to make all the common modifications. That's why, they say if you want to make money in bug bounties, the main thing you want to do is learn Burke. Learn everything on all the tabs. These are all the mistakes people commonly make, and the people who make bug bounties use all these tabs to find everything you can do wrong on a server. All right, so here's the result I want with the discount amount in a cookie, but the cookie is not trustworthy either. I could just modify it. You can change parameters up in the URL if they're up there, and you can change hidden URL parameters. Though you can see sometimes they put them in iframes or an image source or in a form action and so on. And all these things can be modified with a proxy. So some developers will hide things so they don't appear in the bar, but it doesn't mean they're safe. All right, the referrer header we talked about just shows the page that you came from, but it's not reliable. It can be modified, so you can't trust it. All right, we've seen this. Now you can have opaque data. Sometimes you'll see stuff like this, where this is price, but instead of just having the price in dollars, it has a pricing token, which is this long random junk. Now, that could be pretty good if you do it right. If you want to do this, the way to do it is that should be like encrypted and signed or something, so that it is recognized at the other end and no modification will be accepted. It just depends on how good it is. Sometimes it's something very stupid, like the MD5 of the price, or just the price converted to hexadecimal values, and you can still modify it. But there is the mathematics, you're talking to cryptography class, where you encode something and then you put a signature on it, which is cryptographically signed, so that you can tell if it's been modified. Just like signed updates that you get from Microsoft. You can't modify them because the signature won't match unless it was exactly in its original form. So this is called opaque data. So sometimes you can deduce the algorithm if you're doing something stupid. Sometimes you can find some other part of the page that uses this, like you can put in like your phone number, it comes back obfuscated, and it's the same obfuscator. So you can put in the value you want and get the code to do it for you. I've done that a lot when reversing PHP malware. I can't figure out what they're doing, but I find the code that scrambles it and I can just run it, myself. Sometimes you can replay text from another part of the page without deciphering it, and so on. There's various tricks, and we'll play more of these later on. If they've used sloppy encryption, you can still modify the data even though you can't decrypt it. If they used if you use encryption properly, that would be impossible, but a lot of people use encryption sloppily, where they don't get all the benefits they should get from it. Now, ASP is Microsoft server language. You run it on Microsoft Windows servers with IIS, and it's their server-side coding language. So it lets you create this thing called view state, and you can put parameters in the view state, and those are sent to the browser and then echoed back to the server, and it puts them all in a big blob of data like this. The view state is just this long bunch of junk here in base 64. This is called serialization. Java does it too, Flash did it, Silverlight did it. You'd have this blob of binary data in usually base 64 form, and everything was in that blob. Now, in early versions, it was nothing more than just plain text converted to base 64. And that's, of course, not safe because you can easily modify it. The later versions would then cryptographically sign it or encrypt it, which is much better. Then you can send it to the client, and when it comes back to you, you verify it, and if it matches, you know it have not been altered. So that's a serialization error. There are many, many serialization problems where they have this so-called serialized data, and somehow you're able to unpack it and modify it. You shouldn't be able to, but a lot of products in older versions didn't protect it well enough.
Is there a way to break into it somehow? Like
Yeah, well, not brute force.
Base 64 version?
Well, no, base 64, you can just reverse. There's no key. It's not a cryptography. So base 64 is just a conversion like ASCII encoding. Okay. But the question is what's underneath there. And if it's readable text, you can easily modify it. It shouldn't be. What should be underneath there, it should be encrypted text and signed text. So you can't read it, you can't modify it, and it will detect if you alter it. But that's only modern code that does that. That's only modern code that does that. The older code usually wouldn't. So here, for example, is base 64, is view state base 64 encoded. And if you decode it, which I did here in Burke, you can see on the right, it's got price 39. So they just took normal ASCII text and base64 encoded it. And that, of course, is not good enough to stop the attacker from messing with it. Now, some uses a MAC protection, a 20-byte keyed hash at the end, and that would be good. Then you would at least know if it had been modified. I should mention, from the world of cryptography, you can encrypt something, which protects it from unauthorized viewing, or you can sign it, which does not mean it's secret. It just means you can tell if it's been modified. And all you really care about here probably is a signature. You don't really need to encrypt it. You just need to sign it, so you know if it's been modified. All right, and Burke has an add-on to take apart view state. If Mac is disabled, it will just open it up for you, and you can just modify it here. So Burke has the ability to decode Java serialization and ASP serialization, at least the old kind. Anyway, we talked about this, limiting the number of characters. And by the way, sometimes when you refresh a page, you will not get a 200 reply, you'll get a 304 reply, because some browsers have made a local copy. So when you refresh it, they don't reload the page, they just check to see if it's changed. They get a 304 not modified, so they don't get a fresh copy. Now that might be fine if you're just trying to really view a page, but if you're trying to play these tricks in Burke, like reload it with the hidden fields exposed, you really want to reload it. So you have to not do a refresh, but a shift refresh. And you'll see it here in the header. If modified, since there's a header there, you can force a full reload with a shift refresh, or you can use Burke response modification to remove the if modified since header, so that it won't ever fail to reload the page. All right, and then there's script-based validation, which we looked at. There's a form, and it calls this validation script, so you can defeat that a lot of ways. And the simplest way is to just disable JavaScript in the, just modify the response in Burke, or tell Burke to throw away the script. All right, so here's tips. If you're worried about JavaScript, you can just try these things, then catch a proxy to determine if validation is also performed on the server. If I'm only allowed to buy 5, they should have compared the number I sent to 5 on the server, not just on the client. Now, you might want to do it at both ends, so the client doesn't have to send every malformed request to the server, but the important place to do it is on the server. And as you can see, in this case, it did not validate it on the server. All right, so client-side validation might serve a purpose to give the client a simple error message and not bother your server with bad requests, but you can't trust anything that's done on the client that it really happened. And we saw disabled elements too, and you can just, you can just add that field anyway in Burke, even though the form didn't put it there. If you can guess the name of that field, you can just add it, and it might believe it on the server. All right, and we saw this, you can make the form trivial to hack by just turning off all the client-side features in Burke. So let's take a look at a Kahoot, which is, I gotta turn off my proxy because Kahoot is secure and it will not appreciate man-in-the-middle attacks of Burke. So now I should be able